Let's take a look at end behavior of polynomials. So number one, we have 3x to the 5th minus 2x squared plus 5. While we're doing this, well, let's also talk about terms. We're going to kind of take this as a review of all of topics 3.1 to 3.3. So terms, we did this in 3.1. Terms, all you got to do is count how many terms you have. Terms are separated by either a minus sign or a positive sign. So this, we have 3 terms, and remember, if you have 3 terms, that's a trinomial. My degree, take a look. We are in standard form. Notice we're in descending degree order. The degree of a polynomial is the highest exponent. Our highest exponent here is 5. Your leading coefficient is the number in front of the term with the highest degree. If you're in standard form, it'll be the first number that you see. This already is in standard form, so that means my leading coefficient is 3. Now let's pull this together and see what we get for end behavior. Dealing with end behavior, you are looking at your degree and your leading coefficient. On your degree, you're saying, is it even or odd? Well, 5 is an odd number. On your leading coefficient, the question you need to ask yourself is it positive or negative? This one is positive. So this function's end behavior is odd positive. Now, whenever you have a positive function, you're going to have one part of your graph going up and to the right. If it is odd, your end behavior always goes in opposite directions. So it would be going down and to the left. Now, as x approaches positive infinity, so as my x values are getting bigger, what's happening to my y values? Well, if you're going up, your y values are going to positive infinity. If we are moving towards negative infinity on x, so that means we're going down here, x is getting smaller and smaller and smaller. Where are the y values going? Well, the y values are going down. See, this is going to be moving down, which means y is going to approach negative infinity. Let's do another. Terms, we have 1, 2, 3 terms, which makes this a trinomial. My degree, again, we are in descending degree order. This is a degree 4, degree 1, degree 0. So my highest degree is 4. My leading coefficient is negative 2. Now let's see what that means for end behavior. So here, a degree of 4, that's even. 4 is an even number. My leading coefficient is negative. So that means I am even negative. That is my end behavior of the function. So negative. If a function is ever negative, you have something going down and to the right. And if you have a function that is even, your end behavior is going in the same direction. So we are going down and to the left and down and to the right. So as x is approaching positive infinity, my y values are decreasing, so they are approaching negative infinity. And as x is approaching negative infinity, well, my y values are still going down, so they are also approaching negative infinity. Number 3, number of terms, we have 1, 2. 2 terms is called a binomial. The degree is 4. That's my highest exponent. Here would be an exponent of 1. 4 is higher. My leading coefficient then is negative 6. So thinking about end behavior, I am even, negative. So again, this is going to be exactly the same as above. We are going down, down, and as x approaches positive infinity, y is approaching negative infinity. As x is approaching negative infinity, y is also approaching negative infinity. And let's do another. Terms, let's see, we have 1, 2, 3, 4. So 4 terms, we would just say this is a polynomial of 4 terms. There's no special name. My degree, I am in descending degree order. I am 6, 3, 1, 0. So my degree is going to be 6. My leading coefficient is 5. And now let's talk about end behavior. I am, here we go, 6 is even, and this is positive. So end behavior, if I'm positive, I'm going up and to the right. If I'm even, I'm going in the same direction. So that means as x approaches positive infinity, y approaches positive infinity. It's going up. As x approaches negative infinity, where's y going? So as I'm going this way, my x values are getting smaller and smaller. The corresponding y values are getting bigger and bigger. So they are also going to positive infinity. Let's do one more. Let's squeeze it in. And let's do a negative 2x to the 7th, let's say, minus 5. Okay, so this again, terms, we have 2. This is a binomial. Degree is 7. My leading coefficient is negative 2. So for end behavior, my degree is odd. My leading coefficient is negative. So this is odd negative. So if I have a negative function, my end behavior goes down to the right. And if it's odd, your end behavior goes in opposite directions. So this is going to be up and to the left, down and to the right. So as x approaches positive infinity, so as x approaches positive infinity, x is getting bigger and bigger and bigger. Well, my y values, I'm going to keep going down and down and down. So that goes to negative infinity. As x approaches negative infinity, where are my y values going? So as x is getting smaller and smaller and smaller, my y values keep getting bigger and bigger and bigger. I'm going up. So then y is approaching positive infinity.